Right. So iteration, basically, it's a process that enables you to solve or produce an estimate for the solution of any equation that you like, really. I think. Can't think of any reason why it wouldn't work on any equation. This is a cubic equation because the maximum power is 3 for the unknown variable. We don't know how to solve these at GCSE. So if it's already factorized for us, then we can solve it. But if it's not factorized, we don't know. We don't have the tools to solve it at GCSE. So iteration helps us to provide a kind of estimation for it. It's quite a clever technique. What it does, if we have a look at this one up here, for example, then this is a rearrangement of this one here. Only they've got these subscripts. I'll explain the subscripts in a moment. This n and n plus 1. So if I were to make 9x the subject, then what I would do is minus 8 and then minus 9x and from both sides. So on the left-hand side, I've got minus 8, and on the right-hand side, I'd have actually this wouldn't make 9x the subject. This would make negative 9x the subject. So I would then multiply everything by negative 1, and I got 9x is equal to 8 minus x cubed. And then I'd divide everything by 9 to make x a subject. And I'd get that, which looks a lot like what we've got here. But what's weird about this equation is I've got x on both sides. Now, that isn't how we would normally, that wouldn't normally be a good idea, because how can I find out what x is if I'm saying x is something with x in it as well? So it doesn't really work unless you have to do something else here. So what it's given us what we can call a starting value. We'll explain the method of how to do it, and we'll try to understand why the method works. So it's a calculator skill. It's connected to scientific calculators specifically. It doesn't work on normal calculators. So if you just typed in 0 onto your calculator and then press equals, and this is what you're doing on your calculator. I'll do it on my calculator now. Then now in the memory, if you then press the number answer, the key answer, and you get that on the screen, and then press equals, you get 0, because 0 has been stored as the answer. And so, for example, if I were to press 5, take away answer, well, I would get 5. I would get 5 because the answer is 0. Unfortunately, as I've done that now the answer has changed. The answer, this value that's been stored in the calculator's memory as answer has changed to 5. So if I just press answer now and equals, I get 5. So when we're doing iteration and we have a starting value, we want to make sure that we don't corrupt that value in the calculator's memory. So we've got to be careful about what we type and what we do and everything, and just keep track in your head what is in the calculator's memory at the moment. So I'm going to reset the answer memory, the value for answer as 0 in the calculator's memory. And then let's look at this one here now. So if x0 is 1, well, xn plus 1 is this. Well, that would be x1. If we're saying 0, let's write it out. I'm just going to put n as 0 for a start. Okay, and then rewrite all this. So 0 plus 1 is 1, and then 8 over 9 minus x0 cubed over 9. So this is what the n and the n plus 1 is. We start off here, and when I use my calculator to do this, I write the fraction of 8 over 9. I haven't pressed equals yet, and so my calculator's memory still has 0 as the answer key. Instead of writing, I don't write x, I write answer. So basically on my calculator right now, it looks like this. I'll finish writing what it's going to look like. Answer cubed over 9. So I'll just finish doing that now myself. And it's very important that we make sure that we've done it exactly right, because if we make a mistake and press equals, we've now corrupted that memory for the answer and we'll need to start again. So, so we basically then press enter, and we find out that x1 is 8 over 9. Now, guess what? The new value for the answer is 8 over 9. So when we look at x2, which according to the formula is 8 over 9 minus x1 cubed over 9, the formula on our calculator is already set up. So all I have to do to find out x2 is press equals a second time. Now I've got a big long fraction, so at this stage probably what I'll do is just press the SD button and write it to decimal and round it up. So I've got 0.81085. I'm going to write the whole thing. I don't think they expect you to write the whole thing in the exam, but they might want you to write the whole thing when it comes to the final answer. So that'll be my x2. Now that's stored as my memory. So x3 would be 8 over 9 minus x2 cubed, which is stored in the memory, over 9. So what I have to do to find out x3 is press equals again. And I have 0.812965. I'm not going to write it all. Now, if you think about what we're doing here, is we're trying to get it so as x, whatever it might be. If we keep going, if we do this enough time, we'll find out that xn is approximately equal to x. Let me go back a moment. It's approximately equal to xn plus 1 or xn minus 1. In other words, so I'm just going to press equal just a bunch more times. I'm not even going to count how many times I'm doing it. I'm just going to keep doing it. And what I want to do, really, if we're doing iteration properly, is to get it to a point where my value is no longer changing. So, surprisingly enough, I don't actually see many example questions like this, because they usually tell you to do it 3 times, or they tell you to do it a specific number of times, which is a weird thing to ask you to do, because the point is to keep doing it until the value stops changing. So I just did it a bunch of times, and now I can say x is approximately equal to 0.826. So if you did that, hopefully you got this. 0.8691. So let's think about why is that the case? Well, it's because xn was that, and xn plus 1 was also that. Or if you like, let's say I did it 15 times, x15 was that, and x14 was also that. And x16 is that as well. And so I found a value whereby if I put 8 over 9 minus that value cubed and divide it by 9, I get itself. And so it satisfies the equation. If I say that's that, then it's true to say that 8 over 9 minus x, that value works for this equation, which is just a rearrangement of the original equation. So therefore, that's an approximation for the answer for x. Now, you won't be able to. Okay, so the other thing to know about iteration is to know roughly where x is, and And what is often talked about is a sign change. So let's say that we now know what x is. We now know that it is roughly equal to that. So we can say for a start that x is because we know what the answer is. We know that x is less than 1, and it's greater than 0. In fact, let's say it's greater than 0.5. So if we didn't know whether or not it was between these values, and we wanted to find out is it between these values, what we can do is we can take this original equation. Let's write it out again. Minus 8 is equal. Oh, wait a second. No, that's not. The original one was 9x equal to 8. And the way that they like you to do it at GCSE is actually to use this, like I said, this concept of a sign change. So what we do is rearrange it to have the equation equal to 0. So if x cubed plus 9x minus 8 is equal to 0. So let's find out what would it be, what would the left-hand side of this equation be if I put x as 0.5, and what would the left-hand side of the equation be if I put the value of x as 1. So we'll do x equals 0.5 first, and I'm just going to, rather than write all that out again, I'm just going to put that in. So we've got 0.5 cubed plus 9 times, let's use some brackets here, 9 times 0.5, and then minus 8. And I have a negative number, but let's just write it down. Negative 27 over 8. Yeah, okay. Now let's see what would happen if I add x is equal to 1. So I have put that value in. We'll probably have to do this ourselves, actually. It's just going to be 1 plus 9. And then, 1 plus 9, which is 10, minus 8. So that gives us 2. So this is what we mean by a sign change. Between x is equal to 0.5 and x is equal to 1, we're expecting, if for the correct value for x, to have this equal to 0. Instead, we're having a negative number one side and a positive number the other side. If we plotted the graph of y is equal to x cubed plus 9x minus 8, for the correct value for x in this equation, y would be equal to 0, because we're saying that's what that is saying, right?
Okay.
So if we were to plot this graph, when I put the true value for x into this let me start that sentence again. On this graph that I would plot, when x is equal to this, y would be equal to 0. In other words, it would be on the x-axis. So whatever the graph is doing, at some point it's going to go through the axes. Maybe it doesn't necessarily go that direction. It could go that direction, of course. But let's just say it goes that direction. It's going to go through that x-axis. And this point here would be the true value for x. We've experimented and thought, well, what is it when x is 0.5? Or when x is 0.5? Okay, so it's actually, we can see that it's, so x is 0.5 is, let's say, here. And we can see we get a negative value for y. And when x is 1, we get a positive value for y. And so we can see, because there is a sign change, that the value for x is actually between 0.5 and 1. Now, one other thing I would like to say about this is that this idea of a sign change is the way that it's talked about at GCSE, but you don't actually have to rearrange this formula. If I did the same thing with x cubed plus 9x and just, rather than rearrange getting the 8 over the side, and then did it with the same with 1, rather than there being a sign change from negative to positive, instead I just get either side of 8. the same thing would be so. So there's this big fuss about we want to make it so as it's equal to 0 and we get sign change. Just do that because that's what they want you to do. But I think it's good to get a more thorough understanding so as you fully understand the maths behind all this. That there's nothing special about this sign change. It's just that there's a sign change because 0 and positive and negative is either side of 0. But we couldn't. There's nothing special about that. We could have just said, if we got an answer of 8.5 and 7.2, then that's equivalent. That's a little bit like what we've got here for sign change. Anyway, so that's a reasonably exhaustive introduction to iteration. I'll stop the video and we'll have a go at one of the questions.